Alright, in this video we're doing example 4, solving exponential equations. And we're going to be solving these exponential equations using logarithms. So if we have 3 to the x is equal to 7, what I want to do is I want to take the log of both sides, because remember the log property, the one-to-one property of logs say if I take the log of each of these sides here, I can do that because I know that 3 to the x is equal to 7. So once I do that, I now can apply all of my logarithm properties, and the reason I want to do that here especially is because I have x in the exponent here, and so the power property says that I can bring that x out in front. This is going to become x times log 3 equal to log 7. And now here's the fun part, and the reason we used the common log on both sides is because to solve for x we just have to divide by log of 3. It's a common log, so you can go ahead and just plug that into your calculator. And so when you do that, you should get x is approximately or about 1.77. Remember, you could have also done ln in this case. So I could have taken ln of each side, and the reason ln could also work nicely here is because we have the ln button on our calculator. The power property still stands for ln, so I can pull that out in front. That gives me x times ln 3 is equal to ln 7. So x is equal to ln 7 divided by ln 3. Plug that into your calculator, you'll see that you get still the exact same thing here. Okay, part B here. I have e to the 2x plus 1 is equal to 8. So what I want to do is I want to bring down this 2x plus 1 because I need to solve for x. And the way that I'm going to do that is I'm going to take ln of both sides. And so when I do that, first of all, same as the last problem, this power could technically just come out in front, right? So we would get 2x plus 1 times ln e is equal to ln 8. And the nice part here, the reason we chose to take ln of both sides is because e and ln are inverses, and that just becomes 1, leaving us with 2x plus 1 is equal to ln of 8. To solve for x, I'll subtract 1 and divide by 2. We can plug that into the calculator. X is about 0.54. Now the shortcut of kind of just skipping through this step, because we're taking the ln of both sides, we're choosing that because the base is an e. And so these we can just kind of imagine those get canceled, and we just pull down that 2x plus 1. It's the power rule here. It's just kind of shortcutted, so then it just goes straight to this. And then you see what we did there, and we got that x is approximately 0.54. Okay, part C. If you think you can, go ahead and pause this and see if you can give this a try. Alright, so what we want to do, this is similar to part A, we want to take the log of both sides, because we have this x in the power, we want to bring it out in front, and so the safest log to use is either our common log or ln. Let's just use the common log. We're going to take that on both sides. So this x gets pulled out in front, and then we just divide by log of 4. Plug that in, we get approximately 1.58. Now you're asking me, wait a minute, why are we doing the common log again when we have a base of 4? Don't we want to do a base of 4 in our log so that we can cancel that 4 out? The answer is yes, you could do that. Let's see what that would look like. So if I take log base 4 of both sides, it does just kind of cancel out nicely, leaving us with x is equal to log base 4 of 9. And in order to plug that into the calculator, we would use the change of base formula, which is log of that big number 9 divided by log of our base, which is 4, and what do you know? It's the exact same thing. So you can use either way. They both work just fine and get us to the same solution. And thank you so much for watching this video.